Hello everyone, I'm Ramyea R, working as an assistant professor SRG in the Department of ECE in Konga Engineering College. So I welcome you all for today's online lecture on the course Wireless Broadband Communication. So in today's class, we are going to see regarding the topic of mobility management in IEEE 802.16. So basically, IEEE 802.16 is a IEEE standard defined for WiMAX network, that is wireless interoperability for microwave access. So that is similar to Wi-Fi. 802.11 is a standard for Wi-Fi. WiMAX is an enlarged version of Wi-Fi. The standard for WiMAX is 802.16. So in that, initially 802.16 was developed to focus only the fixed broadband access. So later on, it is enhanced to support mobility access also. So in that, mobility management plays a crucial role in order to give mobile access to all the mobile users. So here in mobility management, there are two types of mobility management. One is ASN anchored mobility management. Other one is CSN anchored mobility management. So we will see it one by one. So in ASN anchored mobility management, the sub process involved in mobility management under ASN is scan procedures, association, handover procedures. So uh, before getting into mobility management details, we first see what is ASN anchored mobility management. So ASN anchored mobility management is that this is a mobile station, any mobile station, it may be laptop, mobile phone, or any other wireless gadget, it may be. This is a mobile station, and this is a serving base station currently connected to the mobile station. So if this mobile station is moving to some other place, it has to be connected to other base stations. So that is called as handover. Handover generally means changing or moving the call from one base station to the other base station. That is called handover. If both the base stations are connected to a common gateway number one. Here the scenario shows that there is a gateway one having two base station, having one serving base station and several other base stations also. So all the set of base station has is under the control of one single gateway, which is called as ASN gateway. When the mobile station call or connection is handed over from one serving base station to any other base station, then we call such mobility as ASN anchored mobility, ASN anchored handover, because it is governed by only one gateway, that is ASN gateway. That is called as ASN anchored handover. So this is the flow graph indicating the mobility management. So ASN anchored mobility management has further other a process like scan and association procedures. So scanning process begins. So when the mobile station or serving base station wishes to hand over the connection to other base station, it will send a control signal. That is DCD. DCD indicates downlink control descriptor, and MOB NBR ADV. This indicates mobile neighbor advertisement. This mobile NBR ADV is a message control advertisement message sent to mobile station. It contains this DCD link values and uplink values, followed by the list of list of all other base station that the mobile station can communicate. Okay. So after receiving the list, mobile station will begin to a scan mode. It'll get triggered for the scan. So after the scan trigger, the mobile station will send us control signal called as scan request. SCN means scan request. It is sent to serving base station. What the serving base station will do, it will further connect to other base stations. It may be one or two or any number of base stations it may be. So it will connect to other base station, getting associations. Is there any possibility to connect new mobile station? For that, the control signals will be transferred with other base stations here. Okay, so after communicating to other base station, the serving base station will scan response. RSP means response to the mobile station. So message basically contains the updated list of the other base stations and its details in order to help mobile station to have a proper handover. Based on the signal quality, mobile station will send the ranging signal to other base station, and it will try to connect to the newer base station. Okay. And then after receiving this response message, the mobile station will start scanning after some number of frames. So next is getting synchronized with the target, that is new base station that the mobile station want to connect to. So then it will send the ranging signal for the user equipment. So fast ranging will be done. And ranging request and ranging response will be followed. Request will be sent by mobile station to the other target base station, and upon receiving the response from the newer base station, it will try to associate with the other new base station. So all these process from 6 to 9 belongs to the scanning interval, where only the control informations are being transmitted. After a scanning interval of some x seconds or x milliseconds, interleaving interval will begin. Interleaving interval is mainly to have a normal operations of data communication or voice communication for the mobile station. Currently, the mobile station may require to transmit some data. Even during handover also, it should not get affected. So scanning will be done for some x millisecond. After x millisecond, some y times y millisecond, the interleaving will be done. Interleaving is meant for normal operations. And if there is again scanning is needed, again scanning interval is repeated, and again interleaving will be repeated. This is completely a scan iteration. Both scanning interval and interleaving interval together called as scan iteration. And most scan and normal operations will be repeated based upon the current condition of the connection between the mobile station and the new base station. Okay, upon getting connected to the newer base station successfully, the mobile station will send a scan reply to the old serving base station, indicating that I have got connected to the newer base station. So the serving base station, old serving base station, will disconnect the link from the mobile station. So in this way, the scan and association procedures are being carried out. Association means just exchanging control information, just pre-booking the channel. Just like booking the channel, these procedures has to be done. So in this, we have three or four different type of configurations are available for associating mobile station to the base station. Without association means there is checking of signal quality only will be there. There is no ranging messages are being sent. So that is the first category. Next is association level 0. So in this level 0, it is a very basic form of association without any coordination. There is no coordination in this association level 0. The coordination messages or these messages may have a chance of contention. There may be a chance of collision because of the uncoordinated manner. The third is a bit advanced level of level 0, that is level 1. Here there will be a good coordination between association messages. It has certain ranging intervals. Ranging slot will be allotted to the mobile station in order to send the range signal to the base station. This is about association level 1. Next is association level 2. It is the advanced level of association where the associations are controlled by the base station itself. So here in this category, mobile station need not wait for any scan and request and scan response. All these ranging activities will be carried out by the base station itself by means of a backbone network. It is a highest level of association where the delay is very minimum when compared to all the other three levels of associations. So these are the four major configurations of association used in mobility for 802.16. So next we are going to see regarding handover procedure. So followed by scan and association, a mobile station will be getting a new base station to get connected to. After identifying the new base station, the call has to be handed over. So far scan and association procedures will help to identify the new base station. After identifying the new base station, this handover procedure helps to move the call to the new base station. That is the intention. The handover initiated by the mobile station. Generally, handover can be initiated either by mobile station or by base station. So here the scenario is about the handover initiated by the mobile station. Okay. So whenever it initiates a mobile handover, it will send a mobile handover request to the serving base station. Upon receiving this handover request, the serving base station will send the request to other base station in the nearby region. Then whichever is the applicable or suitable target base station, that will be connected to the base station, to mobile station. In order to do that, the ASN has to approve. The gateway has to approve. So all these signals are again sent to gateway also. Gateway will check the nearby base station and select the suitable base station for this current mobile station, and it will give a context transfer. Context transfer means giving opportunity or giving a suitable base station for the mobile station. So if there is availability, if there is a possibility for Hmm. Mobile base station to get involved in the new target base station, it will send a path pre-register link, which means booking the channel for this particular mobile station. After receiving this path pre-register from the gateway, the target base station will give a HO response, that is handover response to the serving base station. And then serving base station will give again the response to the mobile station, indicating there's a possibility of handover response. Followed by that, it will give the handover acknowledgement to the target base station. From now on, all the packets transferred and received from and to of the mobile station will be buffered. Packet buffering will be takes place, and later on, after completion of all these process only, the buffered packet will be transmitted or received for this particular mobile station. So after confirming the after receiving acknowledgement, it will also indicate the serving base station for a proper handover. HOIND means handover indication. Again, HO will be confirmed to the target base station. So a path will be registering here. Previously, path was pre-registered. Here, the path will be registered. Next, it will give a target base station will give a acknowledgement to the serving base station. Again, the mobile station will begin to range the target base station by giving range request, and it will also receive response for that. After getting response, the handover is said to be complete, and for completion, the serving base station will give acknowledgement. After receiving acknowledgement, the served base station, old served base station will get deregistered from the gateway for this particular mobile station. So in this way, the handover mechanisms are happening. So followed by this, with this, the handover process successfully completed, and the call is moved from this serving base station to the target base station, which is happening inside one single gateway. Hence, it is called as ASN controlled or ASN anchored mobility. So next is CSN anchored handover. In CSN anchored handover, a scenario indicates a CSN anchored scenario where you can see that one mobile station is there, one base station is there, and this base station one is under the control of first gateway, gateway number one, where next base station number two is under the control of second gateway, gateway number two. So currently, let the mobile station is moving from here, this place to this place, then automatically the call has to be handed over. Here, the handing over is done not within the gateway, but between the gateway. So that's why it is called as CSN anchored handover. So in CSN anchored handover, there are two different terminologies. One is proxy mobile IP. Second one is client mobile IP. So this is basically a network layer handover, wherein the ASN handover is a link layer handover. Okay, so that this PMIP and CMIP are the two different mechanisms under CSN anchored handover. And then here this network layer handover supports for two different configurations of IP, that is IPv4 and IPv6. For IPv4, it supports CMIP and PMIP. Both are supported for IPv4, whereas for IPv6 only PMIP is supported. The process starts from cell reselection. The cell has to be reselected from BS1 to BS2 upon giving concurrence from a CSN HA, that is home agent. CSN is a general server or the main server for all these connectivity. So after cell reselections, handover has to take place from one base station to the other base station as per the previous steps explained. So it will synchronize, it begins to synchronize with a new base station, that is base station number two. So after getting into a base station number two, it will try to establish a network reentry process for the completion or successful entry of base station number two. So after this process, the packets will be tunneled through different types of tunneling, type 1 or type 2, R4 tunneling. The tunneling packets will be decapsulated after handover. So all these process involves number 1 to 4 involve a link layer handover, followed by this tunneling. When tunneling begins, it comes under the control of CSN anchored. Tunneling is controlled by CSN gateway. So next, after tunneling, decapsulating and encapsulating, network layer mobility will get triggered, so that the control of the mobile station from this one base station will be moved to the two base station. Again, the control will be also transferred from gateway number 1 to gateway number 2. That is governed here. Network layer mobility will be governing the call transfer from gateway 1 to gateway 2. So after that, MIP, mobile IP registration request will be sent to the CSN for the new mobile station entry. Then reply will be will be sent by the CSN in order to confirm the registration of the new mobile station to the base station number 2. It is about PMIP, proxy mobile IP. So next is about CMIP. That is so it's a CMIP actually. CMIP CMIP, that is client mobile internet protocol. So the link layer handover is not uh, carried out here. Straight away, a CSN anchored handover is carried out. So it contains network layer mobility trigger where the call is being transferred from foreign agent one, that is first gateway, to the foreign agent number two. So here again, agent advertisement will be done from the new gateway to the mobile station. So again, request will be given to the CSN similar to the PMMP, and registration will be done. That is also similar to PMMP. The agent and ADV is the one extra feature added in the CMMP, and then link layer handover is not carried out here. That is the difference between CMIP and PMIP. Hmm. Followed by this is all about ASN anchored handover and CSN anchored handover. So, followed by this, we will discuss about sleep mode in IEEE 802.16e. The sleep mode is important in order to conserve more power and consume only optimal power, and to save a lot of power that is being wasted. So in order to do that, a simple scenario is being shown. One with a mobile service subscriber station MSS, other is a base station. So whenever the mobile needs to go to a sleep mode, it will send a sleep request to the base station. Upon receiving a request, the base station will give a response. This response message will contain time slots. Initial time for sleeping window, that is T1, and then maximum time of sleeping window, that is TN. What's maximum window for this particular sleep? So the initial window, maximum window will be given, and then what is the listening time, listening state L? That particular time is also defined. So totally three time slots are defined from the base station given to the mobile station. Initial time window, initial sleep window, maximum sleep window, and listening window. After getting all these time slot, the mobile station will begin to a sleep mode. So after entering to a sleep mode, it will go to a sleep window of initial T1 seconds, T1 time duration. So after that, it will come and listen to the channel for L time duration. For L time duration. So during the listening state, the mobile will senses the channel for any traffic. Here TRF indicates traffic indication. TRF means traffic, IND means indication. If there are any traffic allotted to me, that is checked by the mobile station in the listening state. If there is no traffic request, it shows negative. If there is a negative, then the sleeping window will start. So now the sleeping window is increased twice when compared to the previous sleeping window, T1. So T2 is equal to twice of T1. That is a concept. Next, after the T2 of interval, listening state will be L. That is constant for all the cycle. So cycle 1 completed with the T1 and L. Cycle 2 will begin from T2 and followed by L. During the L state, again the mobile station will senses for traffic indication. If it shows negative, again it will go to a sleep window. So when the cycle repeats for Tmax time duration. mm, Then if in the listening state, if there is any traffic indication as positive, then the mobile will begin to a wake mode, or else the mobile will continue in the sleep mode. So this particular sleep mode configuration helps the mobile station to conserve more power, but there's a trade-off between the power consumption and also packet delay. For example, here in the T4, T5 slots, whenever the sleep window increases, cycle increases, the sleep window time is also increasing twice. That is T2 is twice T1. Similarly, T3 is twice of T2. In this way, we can observe that the sleep window is increased from every cycle. So here there will be a chance of packet delay. So there is a trade-off between the packet delay and the power consumption of this configuration. So there should be a mathematical analysis to be carried out in order to optimally select the sleeping cycle in order to have an optimum value of power conservation and also optimum value of packet delay. This is the reference book that is referred, Mobile WiMAX towards Broadband Wireless Metropolitan Area Networks. Thank you.